Hello everyone, in this short video we're going to talk about one of the mostly used logic gates called the NAND and NOR gates. NAND and NOR gates are called as the universal gates because you can pretty much implement any logic function. If you have a product function like a plus b, or if you have a function like a bar b, you have a function like a b c bar, you can implement any logic function no matter what using more than one NAND gate. But you cannot do the same thing using AND gates, or you cannot implement the same function using OR gates. So NAND and NOR can basically be used to implement any logic function. So they are called the universal gates. And every other property, such as the number of inputs, the number of outputs, is exactly the same as a typical AND gate or OR gate. Now, NAND, what does it mean? NAND, it implies negative AND. So in other words, we are saying take an AND and negate it using a NAND. That is nothing but a NAND gate. And this is typically written as the AND gate, and this bubble is moved all the way to the end, so that is an AND gate. So we have inputs A, input B, and let's say if this is F, this is G. We all know how to fulfill this truth table here. We have 0 0, AND gate truth table is going to be 0 0 0 1, and so your NAND gate G is going to be the inverted of F, so it's going to be 1 1 1 0, and your truth table for NAND gate is going to be AB and G. That is the truth table for a NAND gate. Now let's look into something called the NOR gate. A NOR gate is nothing but negative OR. So we all remember an OR gate. We have OR gate and negate it with a bubble or an inverter. That becomes a NOT gate. A, B, and this is G. So A, B, output of OR is F, output of AND and inverter is G. So when we write the truth table, this is going to be 0, 1, 1, 1. So G is going to be inverted of F. It's going to be 1, 0, 0, 0. So essentially, the truth table for a NAND or NOR gate is going to be columns AB and column G. That is going to be your NOR gate. These two have been used as one of the most important logic gates used in circuit design. Next one of the most important property is something we're going to see into is called De Morgan's law. It says when you have a property something like this, AB whole bar can also be written as A bar plus B bar, or when you have a property something like A plus B whole bar, you can also write it as A bar times B bar. Okay, this we're going to discuss further in class, but let's see, and let's say these two are the same. So how do you implement this function here? So this function AB whole bar is nothing but a NAND function. So let's see here. You have an NAND function here. This is our function, right? So how do we easily write from here to this? Let's say the way I do it, the simplest way to remember this is when you have product term, literally break it in half and write it as is, and replace the product with the addition. Similarly, you have a whole bar here, break it in the middle, and here you have a sum, so replace that with a product here. So I will explain more about De Morgan's law in class, but for now, let's say remember this as AB whole bar is always A bar plus B bar, and A plus B whole bar is A bar times B bar. And before I close, I want to show you one simple thing here. When I said a NAND gate could be used to implement a new function, let's see what I mean. Let's say I have a NAND gate, something like this, right? Now, we all know this truth table for the NAND gate: A, B, and G. So I have A, B, G. I have 0, 0, 0, 1, 1, 0, 1, 1. The output is going to be 1, 1, 1, 0. Now, right? So what if I combine the two inputs together, A and B together? So see again what I did here. I combine the inputs A and B together. So basically the truth table is going to go from 4 rows to just this row and this row, and the truth table will become A and G, A or B, one of these two. A is going to be 0, the output is going to be a 1, or when input is 1, output is going to be a 0. Look at this truth table. Take a guess on what this truth table looks like. This truth table is that of an inverter. Exactly. So you can take a NAND gate and combine the two inputs together, you get a NOT gate. NOT gate, or also called the inverter. So basically you can take a NAND gate and use certain operations. You can perform certain operations to make it function like a different logic gate, or completely different, implement a completely different function. Thank you.